Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary search tree. That is nothing but convert sorted doubly linked list to binary search tree. So before moving on to the question, if you guys are new to our YouTube channel, then please do consider subscribing it. And if you are the regular visitor of our channel, then why do waste time? Let's move on to the question. So I say this question is a self-explanatory. How? Because after reading this question, I come to know that here we are provided with a sorted doubly linked list and we need to convert it into a binary search tree. So again, I give a short description about the question. Let's move on to the question and let's here create a random linked list. Okay, so I'm here taking some elements like this: 10, 13, 26, 32, 42, 62, 68, 78. I'm taking here the random elements. Okay, so these are the doubly linked lists just because each node have two links, one with the front pointer and one with the previous pointer. So let me make two links of each pointer. So here you can see that some node will store its head. So it is a doubly linked list. Okay, we know it. What we need to do it, we need to convert this sorted doubly linked list into a binary search tree. One more thing which I will tell you right now is that we already know how to convert a sorted array into a binary search tree, into a BST. We already know it. Why do we know it? Well, like how I'm so much confident that we already know it, because we believe a faith, that we have a faith, or we already know it, that the in-order traversal of a binary search tree is nothing but a sorted array, and we use this concept to convert a sorted array into a binary search tree. So I hope you get it what I'm trying to explain, because we already know that in-order traversal of a binary search tree is nothing but sorted. So we use that concept of the sorted array to convert it into a binary search tree. Now let's move on to the another point, that is nothing but a sorted doubly linked list. We will use the same concept that we use in the sorted arrays of converting a sorted doubly linked list or sorted array into a BST. We will use the same concept into a sorted doubly linked list to convert it into a binary search tree. Okay, but the difficult part is nothing but dealing with the nodes, just because we know that because we know if we get failed in dealing with the nodes, we get a null pointer exception. So we try our best so that we will be able to handle it we will handle it very carefully. Okay, so the first thing first is that we will discuss how we convert a sorted array into BST. So let me write here the random array array now. So yeah, 1 2 3 4 5 6 7 8, and let me assign some indexes to them: 0 1 2 3 4 5 6 7. So I'm assuming that this is my array, sorted array, and I need to convert it into a binary search tree. So how will I convert it? At first I find the mid element. How do we find the mid element? So mid is nothing but the beginning plus end divided by 2. So it is 2, beginning plus and divided by 2. So 0 plus 7 divided by 2 is nothing but 3. So either I can take this, means as you can see here are the even number of elements. So for the even number of case, there are two possible candidates. So I'm taking the first candidate, that is the third element. So I'm taking it as my mid element, or I can say it as my root element. Now what I'll do, I'll make two recursive calls with an approach, or with a faith. What will my faith? My faith will be that this part also and this part also will convert themselves into a binary search tree by using the same concept that I use here. Okay, I make two recursive calls with a faith that the left part and the right part of this element of the array will convert themselves into a in a binary search tree. And when they completed this task, when they completed the task of converting themselves into a binary search tree, I'll just update its left and right pointers with this binary search tree. So according to my approach, this part will go and convert itself into a binary search tree, and this part will go and convert itself into a binary search tree. Okay, and the moment it converted itself, I just update its links like this. So this was my approach. Okay, now what we are going to do, we are going to use the same concept or same approach here in the doubly linked list. So let me look how we will use it. So let me create the same doubly linked list here again also, that is 10 13 26, 32, 42, 62, okay, 62, 68, and the 78. Now the first thing, what was our first thing? First thing was finding the mid. It was very easy to find the mid element in the array just because there is a random accessing. Random accessing was easily available in the arrays, but we can't random access an element in the doubly linked list. But we know one thing. What was that? We know how to find the mid element in a single linked list. We have done their program, and we have a great discussion about that on some another video, and the link of that video is in the description box. If you haven't watched that video, then please go and watch that video, just because finding the mid element is prerequisite for this question. Okay, and I'm believing that you already know how to do it. So what was I was saying? I was saying that we already know how to find the mid element of a mid element of a singly linked list. Okay, we already know it. How do we do it? We take 2 pointers, slow and fast. We usually iterate with both of these pointer over my provided linked list with slow as and this slow get updated with a single step, whereas this fast get updated with a double step. And the moment fast complete it iteration, then I can say at that point of time my slow will be nothing but reach at the center of the linked list, or I can say the element which the slow is accessing is nothing but a mid of the linked list. And why it happens, we have already explained it some another video. Please go and watch that video. Okay, so I'm assuming that I have find the mid of this linked list, and the mid of this linked list is nothing but, so this 32. Okay, this 32 will be nothing but the mid of this linked list. The moment I come to know that this 32 is the mid of a linked list, I can bet even that this will be nothing but the root of my binary search tree. Why is it a root of the binary search tree? Just because we already know that this we already know just because the in order traversal of a binary search tree is nothing but sorted, and as it is the mid element of the sorted doubly linked list, so I can say that it is also the root of the binary search tree. Now I will again I will make two recursive calls within approach or with a faith. What will be my faith? My faith will be nothing but my faith will be nothing but I will let this my faith will be nothing but I will apply a faith to this part, this left and the right part. My faith will be that this left and the right part will convert itself into a binary search tree, and the moment they convert themselves into a binary search tree, I will update its left and the right link in such a way that they themselves create a binary search tree. So let's try to understand. Okay, so what I'll do, I come to know that this 32 is a mid pointer. What I'll do, I will find the previous head and the next head, okay, and break them into now two doubly linked lists. Sorry, now I have two doubly linked lists. Sorry, it was nothing but previous tail, actually previous tail and next head, and it is now converting into two doubly linked lists. Now I pass this linked list into one of the recursive functions and this linked list into one of the recursive function with a faith that this linked list convert itself into some binary search tree, and this linked list convert itself into some binary search tree, and the moment they convert themselves into a binary search tree, I update its links with this 32 as the left and the right child. So I pass this into one of the recursive calls. Okay, wait, and similarly I passed it into one of the recursive calls. Okay, now again I find the mid into the left and the right part. So let's find the mid into the left and the right calls. What will be the mid of this part? The mid of this part will be nothing but 13. Okay, the mid of this is 13, so I will make again two recursive calls. The first thing is that I will update the previous tail and next head. I will update these pointers in such a way that this 10 and 26 get converted into two different linked lists, and the moment I update these pointers, this link get breaked, and now we can say that we make two recursive calls again. Okay, so these recursive calls will be made. Similarly, here also I will find the mid of the linked list. When I start searching for the mid of the linked list, I come to know that this 62 will be my mid of the linked list. And the moment I come to know that this 62 is mid of linked list, I will update the pointer, that is the previous tail and the next head, in such a way that this part also and this part also get converted into two new doubly linked list. Okay, these part, the moment this part get updated, this link will get breaked out, and as this link will get breaked out and I get two, and here I have two, sorry, and here I have two doubly linked lists. So what I'll do, I'll pass those linked lists into the recursive functions. Okay, I pass here the recursive function. Now let's discuss these parts. Okay, now now here you can see that it is a single node. This list is nothing but a single node. The moment a particular node come to know that that I don't have any of the children, that I am the single node which is left, so what it does, it revert back to its parent. Okay, this node will revert back to its parent, and the moment it revert back to its parent, that is it revert this 10 revert back to the 13, it update its link with this node. Okay, this 13 will update itself with a 10, because 10 passes some information to the 13. It says that yes, I am the last node, and I have completely created my binary search tree into the left hand side. Similarly, this 26 come to know that I am the last node, that I am a single node, or I am the last node of the recursive call. This 26 passes some information, it backtracks to the 13. The recursive function backtracks to the 13, and it passes some information, and it says that yes, I am the last node, and I am the last node of the array, and I have completely completed my binary search tree. So you can update your right pointer with my position. Okay, so so that's why 13 updated right pointer with the 26. Similarly, as we were making the binary search tree, and each binary search tree have two pointers, either the left and either the right. As 13 have completed its left and the right pointer, this 13 revert back to the 32 with some information that yes, I have converted myself successfully into a binary search tree, so that you can update your link with myself. So that's why this 32 will update its link with the 13. Now let's discuss the part of the 60 of the right hand side. Okay, so here also we have not completed this part, so let's at first complete this part. Okay, we again start finding the mid of this 68 and 78 linked list. The moment we start finding the mid of this linked list, we come to know that 68 is nothing but the mid of the linked list. As 68 is the mid of the linked list, we need to make two recursive calls, one to the left and one to the right. But here you can see that we don't have anything to pass to the left of the linked list. To the left recursive call means we don't have anything to pass here. We don't have anything here, but we have some linked list to pass to the right side. So what we'll do, the moment we come to know, means we need to handle this case very carefully. While writing the code, we will handle it very carefully, but here what we need to pass is that we need to pass the null, as this list don't have anything to pass to its left recursive call, but it passes the null. Okay, and as it passes the nulls, and the moment it backtracks, it comes to know that there is no more element onto the left hand side, and I can say that I have completed my self conversion to the binary search tree. Similarly, this 78 will be passed as a right side or the right child. Okay, so again this 78 comes to know that yes, I am the last child, or I am the last node of the list, and I don't have anything to be passed as the left and the right side, and even if they pass nothing but the null. Okay, so this 78 passes some information to the 68, and it says that yeah, I have completely converted myself into a binary search tree, and you can update your right child with myself. So 68 updates its child, and the moment it updates its child, it comes to know that yeah, I have completely converted myself into a binary search tree. The list I have completed converted into the binary search tree. So what it does, it revert back to the 62. Okay, as it revert back to the 62, the 62 update its right side link or the right child link with the 68, and similarly the same type of information 62 gets from the left hand side, that is 62 update its link with a 42. Why? Just because 42 was the only single child, or was the only single node in a linked list. So 62 also pass the same, sorry, actually 42 also pass the same type of information. So it says 42 some passes like this, that I was the single child. So you can update. So I can see that I have converted myself into a doubly linked list. So you can, sorry, binary search tree, and you can so it says the 62 that you can update your left child with myself. Okay, now 62 passes this information to the 32 that yes, I have converted completely myself into a binary search tree. Now you can update your right side link with myself. At the moment 32 updated its right side link with the 62, it get converted into a binary search tree. So here you can see this was nothing but the required binary search tree. So what approach we are going to use? We are going to use the same approach which we discussed in the conversion of an sorted array into a binary search tree. Okay, I hope you get it, the intuition. I hope you get this try run. Let's move on to the portal and let's try to write the code. So this is our Pepcoding portal, and we are going to write the code here. So the first thing first is okay, wait, let me, now it's fine. Okay, so what will be our first thing? So I hope I think the font size is quite small for you. Let me increment it. Okay, now it will be fine. So what I'll do, at first I'll find the mid. So for that I need to create a function. So let me create a function to finding the mid of a linked list. So here it will be nothing but public static node get, okay, get mid node, and what it takes as a parameter, it will take nothing but the node. And we already know how to find the mid of a linked list, because, and if you don't know how to find the mid of a linked list, then please go and watch that video, because it is a prerequisite for this question. Unless and until you don't know how to find the mid of a linked list, how can you solve this question? Okay, please go and watch it. So let's handle the base case. If node equals to null, and if node dot write equals to null, if any moment we encounter such type of case, we just do nothing but return the node. So let's create two pointer, that is the slow pointer and node fast pointer. So let's update the fast pointer with the head, and the slow pointer with the slow slow. It's slow equals to, sorry, not the head, no, it is node. Similarly slow will be node. Okay, node, where I was writing here. So let's run a loop while fast.write is not equals to null. One more thing about this question is that here the left and the right, or the previous and the next pointer of the doubly linked list is renamed as the left and the right. So what you need to what you need to do is that you need to take the previous and the next pointer as the left and the right of the binary search tree. Okay, you need to deal with them in such a way. So we were writing the code of the get mid node, and we were creating iterating over the linked list. So let's complete it code while fast.write is not equals to the null, and fast.write is not equals to null. Similarly, what we need to do now, okay, we need to update the fast pointer. Fast equals to fast dot next, sorry, right dot right. Similarly, slow equals to slow dot right. So what we return at the last, the moment we come to know that this fast reaches to the null, at that point the slow reach to the mid of a linked list. So we return the slow. Okay, let's complete the code of sorted doubly linked list. We have a faith that the function code we written in the get mid node will work fine for all the cases. Okay, it handle all the cases. So we have faith to this function. Okay, what we does now, again we write the code of sorted doubly linked list. Sorted doubly linked list. So the first thing is okay, we handle the base cases. If head is null, or first case will be if head will be null or head.next will be null. These are the base cases. We always need to handle them. Return head. Now what we do, we make a node.root get mid node, just to get the mid node. Sorry for that. And we pass head to it, and what we get into the root, we get nothing but the mid node of this linked list. Now what we do, node left doubly linked list head. Okay, let's create two head, doubly linked list head. Head, it will be nothing but head if head root null, otherwise head. Okay, so what is it, I will soon explain you. Okay, just wait for some time. Similar, let me write the let me complete this code again. After that I will explain you what I've written here. Root dot write. Okay, so let's discuss it. Okay, so what I have written here, left doubly linked list, why I have written something like this, head equals to root and null. In that case I updated null, otherwise I updated with the head. Why I have written it, just because when there will be a singly node, okay, when there will be only one node and that one lies into the doubly linked list. And okay, let me show you here on the whiteboard, then you get it at which case I'm talking about. Okay, so we encountered this case. Okay, we encountered this case when the 68 and 78 were the two nodes into the doubly linked list, and this 68 will become to the mid of the linked list. And as this become the mid of the linked list, it compulsorily need to make two recursive calls, that is nothing but one to the left and one to the right. And as this node has nothing to pass into its left call, so it passes null. So we need to tackle this case, because if we don't pass anything to this, it will it will give us a null pointer exception. So we need to tackle it. Okay, and the code which I have written here you can see the code which I have written here is doing nothing but it is handling the same case. The moment we come to know head and the root, there will be only one node which is actually available in our means if there is only one node, and that one node means if there is a one, the head node is nothing but the mid node. If that such case encounter, in that case we don't have anything to pass in the left recursive call. So what we need, what we usually pass in that call, we pass this the null, otherwise we pass this the head. Okay, so so I hope till now everything is clear. Let's move forward. If root dot left is not equals to null. Okay, if root dot left, where we were writing the code, so if root dot left is not equals to null, if we encounter such case, what we do, we make a call like root dot left dot right will be nothing but null. Okay, so we have updated here some of the pointers. Similarly, we need to update like what I'm doing here. At first let me write the code, after that we will discuss what I am doing here. Similarly, root dot left equals to root dot right equals to right doubly linked list head, right doubly linked list head dot left equals to null. So what we are doing here, okay, we actually here I'm breaking the links of the nodes. Did here I have find the mid node and I have made it as root. And what I need to do now, I need to make two doubly linked lists, one which lies on the left hand side of that mid node and one which lies on the right hand side of that mid node. And why here I have written this null, why here I have written this null checking condition, just because if there is no left pointer that exists, means if the first node is nothing but a mid node, if such a case arises, that means there is no such left node lies exist, and we need to handle that case, otherwise we get the null pointer exceptions. Okay, so let me make two recursive call now. So root dot left, and similarly root dot right, and we will call this function recursively control v, actually control v, okay, like I think I have not selected it, control c, control v, okay, with some parameters. What will the parameters? Similarly, two linked list that we have created, that is left doubly linked list head. Okay, similarly this right doubly linked list head. So let me update it with DLL head now. DLL head, okay, DLL head. So we need to return something, just because here our return type is null. What we need to return? We just need to return the root, just because at last the moment one of the binary search tree, one of the sub binary search tree converted its converted its conversion to have successfully converted itself into a binary search tree. What it does, it rewards itself to its parent and says that I have completely converted myself. Now you can point your left or either the right child with me and you can complete your work. Okay, so that's all for this code. Let's try to run it, and if we encounter any of the error, we will try to resolve it. So let's try to run it. We get the error here just because we have not, here we forget to write the semicolon. So again let's try to run it. So yeah, here it is one more error because there is no next, there is actually a right. So let's now try to run it, and hopefully it need to get run, just because everything is complete absolutely fine. So let's try to submit it and check whether it is working for all the test cases or not. And it is working for all the test cases. I hope you get it, how to convert a sorted doubly linked list into a binary search tree. Here we have not used any concept, we have not dealt any of the concept. Okay, we haven't learned anything new, we have just used the same concept which we encountered during learning the arrays. Okay, creation of a binary search tree. We have used a concept we have used a concept that the in order traversal of a binary search tree is nothing but a sorted array. So we use this concept on a doubly linked list. I hope you get it. If you like this video, hit the like button, share it with your friends, and let's meet in the next video. Till then, stay safe, stay healthy.